Hello everyone and welcome to this class on cat diaries. So in cat diaries we'll be solving cat problem from the year 1990 to the year 2021. And in this section of cat diaries we'll be solving problems from geometry. Even in geometry we'll start with the topic of lines and triangles. And in that we'll start with the type of triangle feasibility. Okay, so the thought process is very clear here. In the topic there is a subtopic and in that subtopic we see a type. So on triangle feasibility, there are two problems that are being asked from 1990 to 2021. Let's see both of these problems. These problems will ask us for how many different triangles can be formed given the condition. So they will give you some condition in the problem, and on the basis of that condition, how many triangles can you form? That is what they will ask you. So let's understand how do you deal with such kind of problems. So the question here is, what is the number of distinct triangles with the integral value sides and perimeter as 14? Okay, so what do I understand? I understand that there is a triangle here, integral value side. So if I say one of the side is A, the other side is B, and the third side is C, all these three A, B, C are integers. Okay, we know what are integers. 1, 2, 3, 4, they are all natural numbers. If you take a 0, whole number. If you take -1, -2, -3, these are all integers. Okay, so 1.5, that's not an integer. We all know that. So all the three sides are integer. And the other thing I know that the sum of the three sides, that is the perimeter of the triangle, A plus B plus C is equals to 40. Okay, that's all I know till now. So from this, he's asking me, given this condition, how many triangles can you form? So I know something basic about the triangle formation. Okay, when is a triangle formed? When the sum of the two sides is greater than the third side. That is the only when the triangle is formed. There is one more condition to it. When I say that the difference of the two side, okay, is less than the third side, then you can say the triangle is formed. So if these conditions are satisfied, then only you can make a triangle. So these are few basic properties that you are supposed to know, then only you can solve this sum. So I can now solve this sum by putting in certain values. Okay, but before I put in values and help you with the answer to this, let us visualize this property. See, most of us know this property. If you open any booklet or any book, you will find this property there. Okay, but the problem here is we don't visualize. Okay, where did this property come from? Why is it like the sum of the two sides has to be greater than the third side? What will happen if the sum of the two sides is equal to the third side? What kind of a figure you will get there? Okay, and why it has to be greater? So let us first visualize this, okay, before I actually give you the answer to this problem. The answer is there now in just 30 seconds. But I want you to understand and visualize this property. Okay, that's why let's go on and visualize them. So this is the figure as you can see it here. It's a triangle. It has three sides A, B, and C. Okay, A is equals to 10, B is equals to 6.7, C is equals to 8.2. So sum of the two sides B plus C, okay, is equals to what? 8 plus 6, 14, 14.7, 14.9. So sum of the two sides B plus C is greater than A. That's why you see a triangle. Now check it here. Sum of the two sides, I'm reducing the value of B and C. A is still same. Still, sum of the two sides, 6 plus 7 is what? 13.7. So 13.7 is greater than 10. So a triangle is formed. And further reducing B and C. So now B is 5, C is 6.7. So 5 plus 6.7 is 11.7. Still greater than 10. Sum of the two sides greater than the third side. Triangle is formed. Still you have a triangle. 6 plus 4.3. 10.3 is greater than 10. Triangle is formed. Still you have a triangle. 5.8 and 4.3. This is equal to what? 6.1 plus 4, 10.1. 10.1 is greater than 10. Still a triangle is formed. But what will happen when B plus C is equals to A? Sum of the two sides is equal to the third side. 5.7 plus 4.3, that is equal to 10. So when the sum of two sides is equal to the third side, it will become a line. It will no longer be a triangle. That's why you say that the sum of the two sides has to be greater than the third side for a triangle to be formed. Okay, so I hope that this helped you to visualize what is the reason why we apply this problem. Now, since this property is clear, let's get on to our answer. So now here I know that the perimeter of the triangle is 14. Okay, so I'll start putting in certain values and check if the sum of the two is greater than the third. So let's try some value now. What are the values that A, B, and C can possibly take here? So I'll do some trial and error here. I'll say that I can say A is 1, so B is 1, so C will be equal to 12. But can these be the sides of a triangle? Let's check the rule. Okay, sum of the two, 1 plus 1 is 2, has to be greater than the third side. So is 2 greater than 12? No, right? So it is not possible. You cannot take 1, 1 and 12 here. Okay, so is it possible that I can take a 2 and then a 2 and a 10 here? Again, the rule is not satisfied. Sum of the two, 4, has to be greater than the third. Is it happening? No, it is not happening. Okay, you can do this for 3 3 as well. If I put a 3 here, it will be 6. What will be remaining here is 8. Okay, 3 plus 3 is 6 greater than 8? No, not possible. Okay, so this gives me a hint that this I'll do in my mind, not write it here. This gives me the hint that I should ideally start with 4 4, because then only sum of the two can be greater than the third. So let's start with this then. So if I say one of the side is 4, the other is 4, so this becomes 8. So the third has to be what? 6. Now check sum of the two. 8 is greater than 6. Then 6 plus 4, 10 is greater than 4. Then again 6 plus 4, 10 is greater than 4. So all the conditions are satisfied. Sum of the two is greater than the third side. Let's check it if there are any other case. So now this gives me a hint that 4 4 I can start with. I can go ahead with this. So can I take a 5 5? 5 5 and then 4? Is it possible? Yes. 10 is greater than 4. Sum of this two. Then 9 is greater than 5. Yes. Okay, then again 9 is greater than 5 for the rest two. So 5 5 4 could be my one way in which I can write the sides of this triangle. Is there any other way? 4 4 5 5. Let's write 6 6 now. 6 is 12. Now this would be what? 2. So sum of the two has to be greater than the third. So 6 plus 6, 12 is greater than 2. 6 plus 2, 8 is greater than 6. Yes. Again 6 plus 2, 8 is greater than 6. Correct. So 6 6 2 would be my one of the case where the three sides of the triangle can be formed. Now, is there any other case? So let me just modify this. If I put a 6 here and I say I reduce this by 1, so this becomes a 5, and I increase this by 1. Okay, so this becomes what again? 14. Can this be the three sides? Yes, this is again 11. 11 is 11 greater than 3? Yes. Then 5 plus 3, 8. 8 is greater than 6. Then 6 plus 3, 9. 9 is greater than 5. So yes, the condition is being satisfied. Okay, now if you stretch it further and take it to 7, it won't be possible. Because see, if it becomes 7, then the rest of the two will be 7. Sum of the two will be equal to the third. So 7 is not possible. And 3 3 I cannot start with. So I have to start with 4 4. With starting with 4 4, I took 5 5 6 6, and then I modified 6 to see one more case. Okay, so 4 cases are possible where the perimeter is equal to 14 and the triangle can be formed. That is, the sum of the two is greater than the third. So how many such triangles can be formed here? 4 would be your answer to this question. Okay, so not a difficult question. I would rate this as easy question. Okay, the only scope of making a mistake here is writing the cases. Okay, if you know the property and you can write the cases well, think it logically, you can reach on to the answer question quite easily. So let us now see the second problem on triangle feasibility. This problem appeared in CAT 2008. Okay, let's understand how is this problem different from the previous one and what is it like you have to adapt it to reach on to the answer to this problem. So consider obtuse angle triangles with side 8, 15 and x centimeter. If x is an integer, then how many such triangles exist? Okay, so now there is a strong chance that you might make a mistake here. If you don't read this word, obtuse angle triangles, okay, they are not asking me that how many triangles can you form given that the three sides are 8, 15 and then x. That is not the question. The question is, out of all these triangles that you can form with the side 8, 15 and x, considering x is an integer, how many of them are obtuse angle triangles? So I don't want acute, I wanted obtuse. I wanted more than 90 degree. Okay, that is what. One of the angle has to be more than 90 degrees so that the triangle becomes an obtuse angle triangle. That's what we know as a property of obtuse angle triangles. Okay, so there is a chance that you might think in this way. Let me just tell you, okay, this is not how you should solve it, but just to give you an idea about how you can make a mistake here. Okay, I can get on to the answer in 1 minute, but let's understand what is the scope of making a mistake here. So you will say that 8, 15, and x is the side. So sum of the two sides has to be greater than the third side for a triangle to be formed. So sum of this two side is what? 8 plus 15, that is equal to 23. Right? So this number has to be less than 23. So maximum value that x can take is 22. It cannot take 23. If it takes 23, 8 plus 15, sum of the two side will be equal to the third side, which is not possible. Okay, so maximum value x can take is 22. What is the minimum value that x can take? Can I put x as 1? Check it. Then this will not be satisfied. Sum of the two sides has to be greater than the third side. So 8 plus 1, it will be 9. Is 9 greater than 15? No. Right? So I need a number here such that sum of 8 plus x becomes greater than 15. So what will be that number? I already gave you the hint. What will be that number? If I put 7 here, it will be 15. If I put 8 here, 8 plus 8, it will be 16. Sum of the two sides is greater than the third side. So all the different triangles can be formed are where x takes the value from 8 to 22. And what are those values? That is a simple way to check this. This is in AP. 22 minus 8 is what? That will be equal to 40. Okay, this is AP. So first term minus last term divided by the common difference plus 1. That is equal to the number of terms. So 15 triangles can be formed. Given this 3, 8, 15, and x is the side of a triangle where x is an integer. There is one of the option here 15 as well. Okay, so don't make such mistakes. There is a strong chance that at least 10 to 20% of you watching this video while thinking about this problem will make this mistake. He's not asking this. Obviously, answer is less than 15 because the total triangles are 15. He's asking me how many such triangles are there out of this 15. Those are obtuse angle triangles. So let's now start thinking about it. Okay, this is where from the part where the problem starts. So I'm saying that okay, let's make a triangle here, and I'm putting three sides of the triangle. So what can happen? There is one possibility that x is an hypotenuse. Okay, there is a chance, and one of the side is 18, the other side is 15. So this is a chance which could happen. Okay, but then there is also a possibility that x is not the hypotenuse. First, I'm thinking right angle triangle. Okay, from that I'll derive the obtuse angle triangle. So let's make one more right angle triangle because this will help me think how many are obtuse angle triangle. That's why I start with this. So either x is hypotenuse or x is one of the side, right? What else can happen? Nothing else can happen. The side opposite to hypotenuse is the highest. So 15 will be opposite to hypotenuse here. Here x is actually the hypotenuse and the other two sides are 15 and then 8. Now considering the case 1, how many triangles can be formed? So what is the value that x can take? Pythagoras theorem, x square is equals to 8 square 64 plus 15 square, that is 225. That is equal to what? This 9, 289. So x square is equals to 289. So x is equals to what? 17. So x takes the value of 17. Now can x be 17? X can be 17, but that is a right angle triangle. For it to be an obtuse angle triangle, x has to be greater than 17. Okay, understand that it will stretch, it will be greater than 17. So this will also stretch. If this stretches, this will also stretch, right? So it has to become greater than 17. Okay, for this angle to increase from 90 and become an obtuse angle triangle. So x has to be greater than 17. That is quite understandable. So what is the maximum value of x? We saw the range of x that was from 8 to 22. Okay, now from 17, how many values can you take? You cannot take 17. That will be a right angle triangle. So more than 17 and an integer. 17.1 can be taken, but x is an integer. So you cannot take 17.1 here. So I'll take, what are the values? 18, 19, 20, 21, then 22. That's, these are the 5 triangles that you can form considering case 1. So 5 triangles can be formed with case 1. Okay, that is what I understand from this part. Now with the second part, how many triangles can be formed? Let's understand this now. So what is being given here? Here my x square will be equal to 15 square minus 8 square. 15 square is 225 minus 64. Okay, that is equal to what? So x square turns out to be, okay, so x comes out to be as square root of 161. That's what I get it in. So 144 is 12, square root of 169 is 13. So square root of 161 should be between 12 to 13, but more close to 13. So x will turn out to be as 12.8. Okay, that is what I get it as my answer. Now start thinking. If x is equals to 12.8, which means I put it here, I need the values of x which are lesser than 12.8 and are integer value for it to become an obtuse angle triangle. क्योंकि 12.8 पे it will become a right angle triangle. I need the value lesser than this. Okay, so that again this can stretch. If this becomes lesser than this, okay, this will go like this. Again, this will further come like this. So this will become more than 90, an obtuse angle triangle. So I need the value of x lesser than 12.8 and an integer in the range of x. So what are those values? 12, 11, 10, 9, 8. Can you take 7? No. The range of x is between 8 to 22, as we know that. Okay. Below 8, it will not be a triangle. It will become a line, as we had already seen it in the first part. So 5 triangles can be formed here as well, considering case 2. So 5 triangles here in case 1, 5 triangles in case 2. The total number of triangles out of 15 which are obtuse angle triangles are 10, given that x is an integer. So answer here will be option number C, that is 10. Okay, so I will rate this problem as difficult as compared to the previous one. The previous one was just applying the property. This is where you have to actually think. Out of the total, how many are obtuse? What are the conditions for it to be an obtuse? So I first think from the right angle triangle. What value will x take given x is an hypotenuse and x is not an hypotenuse in a right angle triangle? Now from the right angle triangle, what are the values that x will take so that it becomes an obtuse in both the cases? And that makes me reach on to my answer.